So today I'm going to thank you everyone for joining. Good morning, good afternoon, good evening. And today I'm going to be talking about how security, development and testing can work together to stop the same recurring vulnerabilities appearing in the OWASP top 10. So I'm S Chaplin, also known as DevStepOps. You can find me on Twitter, LinkedIn, Instagram, YouTube. I'm in a couple of places. I'm a solutions architect at a company called Secure Code Warrior. But I'm not here to talk about that. So, agenda. First, I'm going to talk a little bit, just about me. Who am I? Why are you here? Why are you listening to me? Then I'm going to look at OWASP top 10 through the ages, because it has changed, but it hasn't changed that much. But we'll come to that in a minute. Then we're talking about the silos. You've got all your different personas. So, who are they? What motivates them? How do we break down the silos? And also, how do we embed security into the software development lifecycle? Finally, I will be doing Q&A on Slack, so you can see the Slack channel at the bottom. It's the topics of interest. So feel free to, ask questions as we go along. I'll be joining the channel at the end to answer any questions. So a little bit about me. I'm going to keep it short, but just for your understanding, I used to be a developer, Java, Python, a little bit of C, but I don't really talk about that. Then I moved into DevSecOps, I really cut my teeth in looking at open source software. There's a company called Sonatype, and that's when I got a real experience of everything DevOps and everything cybersecurity. And I often say about whether it's about security engineers or champions or general people with a passion in security can often start to become a paranoia in security. And I'm definitely verging to the point where I'm like, oh my gosh, the world we live in, are we even safe? But anyway, that's a different story. And right now I am at Secure Code Warrior, which is security training for developers, all about starting left rather than shifting left. So OWASP top 10 through the ages. I haven't gone all the way back because the first OWASP top 10 was actually in 2003. So I'm starting off, with 2007. So we can see we've got some familiar vulnerabilities, injection flaws, cross-site scripting, authentication. So these are vulnerabilities that keep popping up again and again. And you can see as well with the top 10, there's not that much of a change. You can see a couple of things drop, a couple of things added. And similarly, when we then move to 2013 and the most recent official one, 2017, we can see injection flaws is staying pretty much at the top. We've still got authentication, cross-site scripting moving around a bit, but there's a lot of, there's a lot of similarity. So we're seeing the same recurring vulnerabilities again and again. So with the latest version, if you haven't seen it, you should check it out. It's very exciting. But we now have at least the draft, ready for peer review for 2021. And there are quite a few changes in this. And it's not just about the topics, which I'll discuss in a minute, but also the methodologies for how the 2021 were calculated. Traditionally, we look at CWEs. I say we, OWASP, but traditionally OWASP will look at CWEs. And what they found is they were kind of focusing on the top 30. With this year's version, it looked a lot wider. We looked at 500,000 applications. Instead of looking at for 30 CWEs, we looked at 400. So a CWE is it's like a type of vulnerability. So for example, A10 on 2021, SSRF, that is a CWE. Well, say for example, insecure design, which I'll talk about in a minute, is actually a group of almost 40 CWEs. And it's got an average of, I think it said 19.6, we'll call that 20 amongst the different topics. So looking at the actual change, we can see injection has been knocked off the top. It's also been merged with cross-site scripting. We have broken access control. So, all about, permissions, access. When I do a lot of training for salespeople, and I say my simplification for this is don't make everyone admin, have permissions, etc. And something that's really interesting with the latest version is we're looking at the cause, not the symptoms. So we can see the 2017 sensitive data exposure, that's more of a cause, a symptom. And then now we're going to cryptographic failures because that's the usual reason. And the final one that I'm going to talk about, well, a lot, is insecure design, because that is a brand new topic. And the reason I think it's, quite cool is it's talking about design flaws. So as an industry, we're all trying to move left, shift left, start left. We're all going that direction. And with insecure design, it's going, even further, back. We're thinking about stuff like threat modeling. We're thinking about secure design patterns and principles, reference architectures, because you need to start thinking about, you need to design securely before you start coding, implementing, etc. Security cannot be an afterthought, because that's kind of how we've got in this whole situation of the same recurring vulnerabilities, and why I am speaking to you now about this. So I think of it a little bit like an iceberg, because OWASP top 10, that's why we're here. That's the ones we've got to focus on. But take, for example, I mentioned SSRF as the new number 10. So CSRF was actually in nearly all the other years. So we talk about the OWASP top 10, but what about OWASP 11, OWASP 12, 13? Obviously, we don't rank those, but security is not, the OWASP top 10 is awesome, and they are the most, prevalent, but there is a whole iceberg of what we need to look at. Others of you may know the SANS top 25. So these are the top 25 CWEs. And this is the thing, your scope's going bigger. And right now we're talking about application security. Very important. What about, cloud security? We're all migrating at the moment, networking, environments, mobile, IoT. It's not just, design vulnerabilities, SSRF. There's a whole iceberg out there, and I put this at the bottom, but we don't ever like to talk about it. What about human error? It can be innocent, it can be tiredness, occasionally malicious, but that's a different topic. But a lot of vulnerabilities are caused by that, and I've even got a stat, I think, on there in a few slides time. Oh no, it's on this slide. So I've got a couple of stats here. I'm not going to read off the slide as such, but maybe if I look at the very bottom, the average cost of a data breach is nearly 4 million. And when we look at that, okay, does that take into account brand? Because there is a very famous organization that had a bad version of Struts in about 2017, and they lost 1/3 of their market cap. Like they lost, I think it was something like 5 billion. It was pre-GDPR, otherwise they would have been heavily fined. And I'm not going to name and shame, but anyone in the open source space probably knows who I'm talking about. And in terms of with brand, it's been 4 years later, and people, still know who this company is. So, no one wants to be on the front page. And a lot of these vulnerabilities, or the attack vectors, are web-based. So, coming from, the application code. So this is something that we do need to focus on, as well as the rest of the iceberg. My other stats, okay, slightly old, because we've obviously got the 2021 version as of very recently. But injection flaws is still in the top 10. It's been number 1 for like, I don't know, what was it, like maybe 10, 14 years. But this is the thing, it's the same vulnerabilities. Funny story, our CTO used to be a pen tester, and he was aware that the same recurring vulnerabilities kept coming again and again. So he's like, okay, so how do we fix this? Okay, who's writing the code? Let's go to the source. Let's work on the cause of this. And here we have Secure Code Warrior. But anyway, and the final one of my stats. 25% of all data breaches last year were caused by human error. And that's the thing, we are humans. We can write as many tests and have as many security protocols as we possibly can, and that's great, and we should continue doing that. But sometimes people make mistakes. And it's not just in security. I think there was an article I read a few years ago, and it was talking about some of the most costly mistakes ever, but from a finance perspective. And it was in Japan, and I think it was meant to be, one share was 225,000 yen. Accidentally got the numbers mixed up. So they put 225,000 shares for 1 yen. And I think it knocked like, I don't know, I can't remember, it's like 5 or maybe 11% off the Nikkei for the day. I wouldn't have wanted to be that person, if I'm honest. So anyway, this is the thing. It's not just tech. It's not just security. It's, we are human. Things happen, and we need to try and prevent this. So let's talk about our personas. So I put testing on the left with a little power button. We've got security in the middle with a little shield, and then I've got my developer in my brackets. And this is the thing, we're all very, very siloed. So my background, I used to be a developer, so it puts me kind of in the right. And now I work in security in the middle. I've done a bit of testing, but anyway, we all have very, very different motivators. Developer, we like our new and shiny. We like to do things. We're usually quite creative. I like to think we're quite intelligent. We're into problem solving, and we like to focus. And we also like our tools. You know, if it's outside our IDE, it might not get attended to very often, etc. And that's the thing. Developers are motivated by, you know, features, functions. They've got their deadlines. We've got our sprint cycles. You know, that's our game. Security. They're trying to find the problem. And the thing about security is you can find one problem and you kind of done your job. And developers, on the other hand, have to make sure everything's you know, secure. So it's definitely an interesting paradigm. And they speak different languages. So I talk a lot about username enumeration because I've got some developer friends. And I say to them, I'm like, do you know what username enumeration is? And they start talking about, you know, type enum and going down this path. I'm like, okay, I understand why you think that because I'm an ex-dev. I'm like, actually, it's when you're logging in, and if you get your password wrong, and then the application says to you, your password is wrong, then you know, hacker knows, oh, I've got the right username. Let's, you know, brute force this. So, you know, when I was talking to my developer friend, he smiled. He's like, oh yeah, that happened to us. So that's the thing. It's the lexicon, it's the terminology, it's the motivators. And then you have testers as well. And testers are kind of, I'm not going to say like a hybrid. They're obviously motivated by, you know, getting all the tests done. But I've been reading the Unicorn Project recently. And one of my favorite moments is when the main character decides to throw a party for testing. And all of testing are really surprised, like, oh, wow, no one's ever thrown us a party, you know, for testing day. And that's the thing. It's about understanding how to motivate your different personas. So, example, throw them a party. That's not always practical. I actually had a friend who worked at Co-op. So Co-op is well, it's a large organization, but he was specifically in the supermarket in the food area doing new research and development for food. So he had a big fridge. So whenever he needed something, say off finance or other department, he'd walk around the head office with like loads of cupcakes, and then he would ask the person, oh yeah, I kind of need that thing. Oh, do you want a cake? So that isn't always possible, you know, in a virtual world. But it's all about understanding who and what motivates them, because a lot of the time when you get developer and security, it can go it can go either way. And what we're really trying to do is, it's almost like the year of the empath, you know, 2021, security's not the bad guy, neither is testing. Developers just want to do the best thing possible. No one wants to be on the front page. So how do we achieve that? And also, why do we achieve that? So part of the reason, the old bugs keep performing new tricks. This is an example of SQL injection. You know, SQL injection came out in about 1998. Guess when the fix came out? Also 1998. So we're looking at about 23 years of the same vulnerabilities appearing again and again. And this problem isn't going away because, to quote Notorious B.I.G., more code, more vulnerabilities, because we've got obviously the number of developers is increasing. We've got, you know, number of languages, number of environments. Now everyone has a mobile team. You know, you've got your cloud team. You know, it's not just looking at, oh yeah, my web-based server anymore. It's you've got, you know, such a massive scope. So head to the source. Just like with our new OWASP 21, we want to look at the root cause, not the symptoms. Like, I love testing. Testing is great. You've got SAS, DAST, OWASP has so many amazing tools for that, but you can't test your way to the solution. Testing will help you find it, but it won't necessarily help you fix it. And this is what we're trying to do. Break the cycle of recurring vulnerabilities. And this is actually, this is one of my favorite slides, and I'll tell you why when I get there, but I'll talk you through the flow. So we're going to start in the top left where it says bug reappears. I'm going to pretend it's bug appears because we're starting the flow. So bug appears. Okay, there's a bug in the system. Then the security will step in. They will test, they find the vulnerabilities. For security, it's like, okay, we found a problem, it needs to be fixed, you know, we can't release this is a big deal. So at which point they will probably put it into a bug tracking system, loading the results. At which point security is like, my job is done. I'll make sure it's fixed, but I've done my bit, etc. And this is the bit of the slide that I like. Developer finds way to fix the problem. Is it the best way? We hope so. Is it the most efficient? Is it the accurate way? Is it a case where the developers, behind budget, behind schedule, tired, might not even understand what the vulnerability is and says, oh yeah, false positive. Oh, this doesn't affect us. I'm not using that library. It's fine. And this is the thing. Our developers, do they know the best way? It's like I mentioned, the username enumeration. Does a developer even know what that means? Does the developer have the bandwidth to go Google it and go read up on OWASP and understand this? We need to think about, how we can, level up everyone, make everyone a security champion in terms of have that basic level. And the same with testing. If we can get even testers, whether it's pen testers, whether it's, running the testing tools, etc., being able to understand, have this mono-supportive culture, where it's no longer a case of pointing the finger. It's like, let's fix this together. We're all on the same team. We work for the same company. Let's get it done, etc. So my developer has found a way to fix the problem. But guess what? Retention's a little hard at the moment with development. People move teams. People move orgs. And the knowledge that was obtained disappears into a black hole. And guess what? Then the bug reappears. Then we start this cycle. And working in development, it's bad enough fixing your own problems, like, your own vulnerabilities. But it's even worse when it's someone who left before or has moved team, and then you're trying to understand other people's code. And it starts to become, difficult, monotonous. Developers don't really, it's not our favorite part of job. We like creating, but, I've heard some stats. Well, I've heard some stats about developers spend about 9% of their time writing code. And when I started in development, I was told I'm going to spend 10% of the time writing and 90% debugging. And I'd say that's pretty accurate. And like I say about the OWASP top 10, there isn't, there's more, it's an iceberg. There's more than 10 vulnerabilities. If you look at NIST, there's over 125. When we look at the top 21, there was a total of 400 CWEs. And that can be, like I said, from SSRF, CSRF, etc., to much broader, like authentication, for example. You've got a lot of different, CWEs associated with that. So how do we embed security? Some people talk about DevSecOps or SecDevOps or Secure DevOps, and they just assume it's like a line in the middle. Like, okay, we've put some SAS scanning, or we've got some testing as part of CI when it goes from Dev to Ops. We're doing security, and it's not quite that easy. So there are a lot of, the best advice I can give is embed security at every step. So part of the reason I'm so excited about the new insecure design category is because we're starting to look at the plan stage, threat modeling, policies as code is a really growth area. So we need to, even before, we have, pen to paper, finger to keyboard, we need to start thinking about our architectures, having, this secure by design approach. Then when we're obviously coding, we're going to start doing, maybe some SAS scanning. We can also do peer review. I like peer reviews, but they're normally about the functionality. Is the person peer reviewing? Are they a security expert? They probably think they are, but are they? And that's the thing. A lot of the time we're reliant on, I want to say optimism, but it's like, yeah, no, it's fine. Don't worry about it. Let's just get it through, because we all have deadlines. We all have priorities. No one wants to be there at, 7 p.m. on a Friday with a broken build and fixing vulnerabilities. Well, I'm not going to stereotype. I'm sure some people do, but you know what I mean. So all of the things I've been talking about so far, more in the dev stage. You've also got penetration testing as well. But then we have the whole ops stage. And I think that's sometimes overlooked a bit. Like, for example, the old A10, I think it's now A9. I am one of those cool people who knows my OWASP top 10. But it was called insufficient logging and monitoring. And this is really understated. This is so important because inevitably, touching all the words, Unfortunately, whether it's on a personal level or on a professional level, we probably are all going to get hacked one day. I actually got my, what's it called? You know, the gaming Steam. I got my Steam account hacked just before I went to a conference in Sweden a few years ago. And I was like, oh, wow, it's happened to me. Maybe this is the only time, fingers crossed. But anyway, that's why logging and monitoring is so important, because the company that I mentioned, you know, from 2017, it took them 3 months to notice that they were being hacked. Imagine how much damage you can do in 3 months. And if I was going to look at the whole of security, obviously everything is important. But for me, one of the most important areas is your incident response team. You know, okay, you've been hacked. How quickly can you notice? How quickly can you kick them out? How quickly can you contain, you know, what's going on? So it's really important to have this at each stage. And, you know, traditionally we think of developers, you know, on the left and up on the right, but it's really about having this understanding of all of these different security checkpoints. Because think about poor security, they have to be aware of all of these stages. And we're just talking about AppSec at the moment. So what about with the cloud? You know, okay, so, you know, if we're using containers, are we doing container scanning? Where are our containers? Are they in Kubernetes, or are they also in, you know, the cloud as well? So there's so much. So that's why I really say that it's not about just all the tools. Like, you could buy all these tools, and are you doing DevSecOps? Well, you're on paper, potentially, but it's much more, it's a culture piece. It's a people piece. It's about, you know, the empathy. It's no longer pointing the finger at the bad guy, etc. So yeah, changing culture is key. And this can be done in multiple ways. You know, bottom up, top down, say middle up and down, etc. But having a, you know, we want to get rid of the culture of fear. So even when we look at W. Edward Deming, who did all the car research, you know, back in the kind of 60s and 70s, even then he said we can't have a culture of fear, because if there is a problem, we need to report it. We need to find out what happened, how it happened, how to make sure it doesn't happen again. And the person reporting or whistleblowing needs to feel safe. Like, if that person feels that they're then going to be, you know, fired, then you know, they're probably not going to, they might falsify things, they might sweep things under the carpet. I was reading a lot about fear culture recently, and the example they gave was Nokia, because I think we all remember the Nokia mobile phones and the monopoly they had. And actually, part of what went wrong, we all think it was to do with the Apple and the iPhone, but actually, if you do read up, it's quite interesting. It was as well to do with the culture, because there was more of the top level management, you know, wanted growth. The middle management were a bit terrified, and obviously the bottom level were just doing their normal job. But because middle management didn't, you know, there was a fear culture, they were afraid to, you know, report the truth, there starts to become a disconnect. And this is the thing, that it's the culture. This shapes the values and attitudes, and it shapes the actions. So we talk about, you know, all of the security tools I talked about before and all your different personas. But we just have to remember, we're all trying to do the right thing. Security aren't the bad guy. You know, testing is absolutely fundamentally necessary. Developers are very busy, but, you know, they've got a lot on their plate that they need to, you know, be able to relate to all personas. And I think at the moment, everything's virtual and we're all remote. As we gradually go back to offices, we'll see what happens. But that's kind of almost my most fundamental message, you know, of this. It really is about understanding the people, changing the culture. And you can do that as an individual. You can do it as a senior management. It's really about taking a more progressive and empathetic approach, so that you can resolve all the security issues together. Because, like I said, the same recurring vulnerabilities keep appearing. I think that would be something I'd love to see. It'll probably be by now 2025. But if we could just change them, because we're like, guess what? We solved the OWASP top 10. Now we're focusing on 11, 12, 13, you know, up to 20, etc. But, you know, we'll see. I'm always an optimist about this. And this is something that I like to think of. I did kind of allude to it earlier, but security champions. We often think of these as developers. I call them either with a passion or paranoia about security. But why do they have to be developers? Can't a tester be a security champion? What about someone in finance, you know, who's with the CFO being like, yeah, I've been reading about ransomware in the news and I heard about the pipeline in America. I think we should invest more. Let me give you some more discretionary budget, you know? It's about really having this security first approach, no matter who you are. So that as well, you know, security champions doesn't have to be developer. It can be anyone. You can be in security and you can be a security champion. So to summarize, Security threats are ever evolving, and a developer-led approach is needed to detect and eliminate risk. And I think especially with eliminate, because we're great at detecting risk. I'm sure everyone out there in an enterprise org will have multiple, multiple reports, red risk, orange, CVSS, it's bad, but we really need to focus on eliminating the risk. How do we do that? Embedding security at every stage and breaking down the silos. And it's not just between the three personas I've mentioned, between the commercial team as well, between project managers, etc. And finally, changing culture is key, and giving teams the tools to do that really helps. A funny story just before I close. There I was a few years ago, taking a train home to my parents, just on Instagram stories. I see a friend of a friend. She works in fashion. She's working at her uncle's startup, doing social media. She's editing HTML on a Word document, and she captioned it "Oh my God, coding's so hard." And I'm like, if you're literally changing tags and colons and everything on Word, of course it is. At which point, I sent her a message. I'm like, babe, have you ever heard of an IDE? But anyway, it's a bit of a silly example, but give the teams the right tools, change the culture, avoid fear, embed security at every stage, detect and eliminate risk. So thank you so much, everyone, for listening. I hope you have a great rest of the day. I know there's some really awesome sessions. If you've got any questions, I'll be in the Q&A. You can find me on Twitter. You can find me on YouTube, Instagram, or under DevStepOps. I've got my email, LinkedIn as well. So yeah, happy to answer any questions, and thank you so much for listening.